Okay, so here I am. I'm on number 14 in that quadratics page. So the first thing we need to do is something that you always skip, you guys. We need to find a GCF. And there actually is one here this time. So it's really important that we understand that. My greatest common factor here is a -1. I know that's weird, I know it's gross, but it's just because that front number is a negative, we have to take that negative out. We want to go and put negative x squared plus a 4x minus a 5. Something that's important to understand here is that standard form happened at the beginning, before I factored anything out. A greatest common factor means factored. Okay, so if I'm looking here and I identify my root, or I look here and I'm looking to find my standard form, it's the negative x squared minus 4x plus 5. From standard form, my easy point to find is my y-intercept, which is the very last number, which is 5. Okay, so I'm still factoring, but I wanted to point that out to you, that my y-intercept is 5, it is not -5. I also want to point out that my graph should be concave down, which means that it should have a maximum. I need to go find my roots, which means I need to keep factoring. I'm going to go through and I'm going to white this out so that I have a little bit more space. To work around. So I'm going to go ahead and make an x. In the top of my x, I get -5 because -5 times +1 makes -5. On the bottom, I'm going to put a +4 because it's a +4. 5 times -1 would multiply to -5, add to -4. This allows me to then go and do my box method. Some of you are going to need some extra space to work here. And that's okay, you can go off on a separate sheet. I want you doing the box. I don't want you cheater-cheatering. I don't want you going and taking a shortcut because a lot of you are going to forget. We're going to put a positive x squared here. We're going to put a -5 on the bottom. So that's weird and different from what we've done before. Because we factored out that negative, it becomes a -5 on the bottom. I'm going to put a -1x in here, and I'm going to put a +5x in here. Those came out of my x's, so they come with x's. I get x and x on the side. X times -1 makes -1x. X times +5 makes +5x. I can even go and double check my work. -1 times +5 makes -5. So I'm going to go through and I'm going to write down my factored form, which is going to be -x minus 1 times x plus 5. It is important that you understand that there is a negative there. Okay? That it's not right if the negative isn't there. The negative is what tells me that this is concave down. From here, I can take my opposite x to get my roots, or my zeros, or my x-intercepts, whichever way we want to call them. It's still opposite, even though there's a negative in the front. I'm going to zoom in. I'm going to put my points on +1 and -5. +1, -5. 1, 2, 3, 4, 5. Okay. I'd like to point out that right now we could go and find our axis of symmetry by counting. 1, 1, 2, 2, 3, 3. Put our line of symmetry right there. We could also go and do math work to get our line of symmetry. So we could go and use the formula negative b over 2a, where my b was -4, so it would be negative, negative, and my a was -1. This turns into a +4 over a -2. This gives me x equals -2. Double check. 1, 2, x equals -2. From there, I need to go ahead and I need to plug in to get my answers. Okay, so I'm going to zoom in again. I'm going to erase some of my work so that I can show you new work. If you need to go off to a separate sheet of paper, that's totally fine. Okay. What am I working on doing right now? Finding the vertex. So I have my x's -2. So I'm going to go -2 squared -4 times -2 plus 5. -2 squared makes a +4, but the negative was still in front to keep it there. -4 times -2 makes -8. +5. -4 and -8 make -12. -12 plus 5 makes -7. So I already had the x of my vertex. It was -2. I know that this gets parentheses because it's 1 point and 1 point only. I get -2 comma -7, and I put it in parentheses. I come here, I zoom in, and I go 1, 2, 3, 4, 5, 6, 7, which just happened to be about how far my line went. That was super lucky. It was not something that I had planned on doing. Okay. So here's my line of symmetry. That's my vertex point. Right now I only have 3 points on my graph, so I need a couple of more. I have a y-intercept that I didn't go through and put there. So I need to go and do that. So that's a +5 is my y-intercept. Something's weird here. Do you see how I went through and I was like, this is not going to work out. There's something weird going on. So I'm going to double check myself. This should be concave down, which means that my vertex should be a maximum. Right now my vertex is at a minimum. That tells me I did something wrong in my equation over here. So I'm going to go double check myself. -2 squared. This makes a +4 and a negative. -4 times -2 and negative times a negative makes a positive. That's where I messed up. So let's go double check this again. So instead of being -12, this should be a +4, which should make this a +9. So let's scroll down. We'll go right here. This happens. When you get to your test and you see that happen, you know you did something wrong. Go back and check your work, because it was probably just a tiny mistake like what I just made. And it's something that you can fix. Don't go, well, I got the problem wrong. No, you guys can do this. +9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, my line just ended up being there. It was not planned that way. 1, 2, 1, 2. I mirrored my y-intercept over, and I'm getting this concave down graph right here. This concave down graph has arrows going on it. Make sure that you have that. Those are my at least 5 points. I'll leave you to do domain and range. And there goes my lights. I guess I've been here too long.